Okay, for all of these, when we're solving for the you want to decide which quadrants we're going to be in. So I look at my first example and I see that it's sine. Yes, Katie? That's what I'm about to go over right now. Okay? So I'm going to, we say sine is y over r. And r is always positive. Sine is y over r. When I do y over r, is this a positive or a negative number? So we are looking at where is sine positive. That's what I'm talking about, positive or minus. We're looking at where is sine positive. Sine is y, so it will be positive if I go x up, or if I go negative x up. And these two quadrants are where sine is positive. So I know that my answers are going to be in quadrant 1 and quadrant 2. So that's my first step. Now my second step is like actually find the theta. So if I was doing this the way I showed you the other day, rewrite it over here. What cancels out sine and just theta? What is that called? It's not called sine to the negative 1. What's it called? Inverse sine. So we do inverse sine, which looks like sine to the negative 1. It means inverse sine. We do that to both sides of the equation. That's the only thing that cancels out sine. We get theta by itself. So then we're going to do that on our calculator. What mode should we be in? Why? Huh? Why? Why? This is not an angle. This is the part that people get confused about, and this is why I'm not trying to be mean when I say it. What? It doesn't matter yet. But what I want you guys to understand is this number is not an angle. This number is after we take the side of y and divide it by r, that's the decimal we get. The angle, I don't know. So it does not matter if you're in radians or degrees. I'm going to do this in degrees because as we're just learning it, when we get a degree answer, it will make more sense to us that we are doing it right than getting a radian answer. It's just going to make more sense to us that we're doing it right. If I get 300 degrees and I look at my picture, is 300 degrees a possible answer for one of these? No. See, I'm going to use degrees, so it's going to help us know that we're doing it right. Okay? So I have mine in degree mode, and I'm going to type in second sine 0.3892. And I get, let's see, it's nearest hundredth of a degree, so 22.90. This is the reference angle. Well, it could be the reference angle. Maybe I shouldn't write that. It could be the reference angle. It might not always be, so let me take that back. What that is saying is that 22.90 degrees. Is that one of the thetas I'm trying to get? For degrees is going to be 22.90. But I also need to get the second answer, which starts here and rotates to here. So this is not doing a full 180. They're right here. I take 180 and I subtract off my answer, which is 22.90. I'm going to use my calculator and I'm going to do 180 after the answer. Do you guys know how to use the answer button? Are you doing it with me or are you just watching me do it? Be best to do it with me. Katie, do you have a question? Okay. So it's only going to do the answer if that's your last answer. and I get 157 point, how do I round this correctly? 10. So we have our two answers. Now, so I have two choices. I could change my mode to radian and do the same work. Convert my answers to radians. Either would be fine. So if I were going to use my calculator to convert, I want to do the least amount of work possible. So for me, if I were going to convert, I'd probably start with this one, and I would hit times by, what do you have to times by to convert degrees to radians? Pi, divide by 180. So that's the second one. To hundredth. So 2.7. And then I'm lazy. Up thing, you can go grab it. You guys, you know I'm talking about the up thing. If you don't have the up, go grab it. If you have an older calculator, what I would do is I would hit second enter, second enter, second enter until I got that same question that I already asked. Or actually, maybe I don't know what I do. I don't know what I do. This is maybe what I would do. And then I would do the same thing again. I would do times by pi, divide by 180, just to convert that one. So 0.39, so I'm doing the hundredth. That's going to take the 9 and make that a 10, but that makes it 0.40. So one last thing, you just, Amelia.
So like how you subtracted the radian like for 5 degrees by 180, did you just subtract it by pi and replaced it?
Yes, if you change your mode.
Yeah.
Yeah, if you change your mode, sorry, I should have done that too. You do it that way. So if you change your mode and you type in, you just retype in again that same question, then minus, oops, okay, minus, one more time, pi minus the answer. So instead of 180 minus the answer. And then there's my two answers, the exact same. Now, do that I would highly suggest is just make sure that you're rating 180 as a radian in decimal form, 3.14. And then this top one here is half of that, so it's 1.57. This one's obviously 0. Does 0.4 seem appropriate to be in this quadrant? Does 2.74 seem appropriate? All right, so another one, same stuff. There's two more, they're just the exact same stuff. Example 7, we're going to do secant of theta equals negative 2.3412. Okay, so the first thing I do is I look at the fact that this is negative, and I think about what secant is. Cosine is x over r, so secant has to be r over x. So where is x negative? Second quadrant and third quadrant. This is where x is. So my answers will be in the second and third quadrant. Now I don't have an inverse button, so I can't go straight into doing inverse. What do I do first? We learned this like, I don't know, a week and a half ago or something maybe. Here 1 over cosine happening there, right? We have to reciprocate something. I want it to be 1 over cosine. I want it to be cosine. So if I change this side, what do I have to do to the other side? I gotta reciprocate both sides. Okay, if I reciprocate the first side and make it cosine, then I have to reciprocate the second side. So now for this, now we can do cosine inverse to both sides of the equation. Put it in degree mode. If you're following my graphing calculator, put it back in degree mode. So we'll do second cosine 1 divided by negative 2.34.2. I got 118.29 degrees. Does that make sense for my picture? Does it make sense for me? Yeah, that makes sense. That is not the reference angle, though. Remember, I was like saying that before. It's not the reference. It's actually the first answer. That 115 is starting at 0, going to there. That's 115. So now we need to figure out the other angle. And there's different correct ways of doing this. So I want you guys to use logic. How can we figure out this red angle? Oh, it's going to be more than a base. Anybody have an idea? I can think of 2 different ways that are both correct. You guys are in pre-calc. Somebody help me out. Neil? Whatever theta is. What theta is, can I find out what theta is? Okay, so I can find out theta by taking 180 degrees and subtracting off that last answer. That's going to give me that reference angle theta. And from there, my second angle is going to be 180 plus whatever theta is. So I'm going to use my calculator to do this. I'm not going to be rounding things. I'm going to say 180 subtract that last answer I got. And I get 64.71. Okay, that is the theta. That's the reference. And I'm going to take that answer and I'm going to add 180 to it. 244.71 degrees. Does that make sense for this third quadrant? This is 180 here. Oops. And then down here is 270. So 244.71. Question? What do you need? My work or my calculator? What do you need?
Your work.
So the answer calculator. Yes, Neil?
How come when you do like the inverse cosine of the 1 over negative 2.34, how come that gives you like the angle instead of theta? But in, like in the first one, it gives us the...
Well, it gave us the angle also, right? Because in the first one, angle and theta are the same answer.
Yeah, right.
Okay? But in the second one, it gave us the angle. So what it gave us is it gave us the angle for both of them.
So anytime you do inverse of like sine, cosine, and tangent, it'll always give you the angle, like not theta.
Correct. Now, sometimes it is the same answer. Yeah, which is why I erased when I've written that before. Sometimes it's the same answer. Now, you will notice it only gives you one answer, and we're going to learn about that later in our pre-calculus curriculum. We will learn about how it only gives us one answer. Now, it is only going to give us one answer, and you have to find the other. Okay? And one of the answers will, actually, sometimes you're going to see this, I think the next one, is sometimes it's not even going to give us either of the answers. You ready? Let's keep going. So what I did was, I found out my theta. I subtracted that from 180 so I could find, or to find theta, subtracted my answer from 180 so I could find out what was left over. Then I took that same answer, added it to 180 so I could find out the second number. So if you were going to do this with radian, if you change your calculator to radian mode, the work that work, but you would use pi minus answer, and you would use pi plus the theta. You would just use pi instead of 180. Or you can just go up in phase and you can, just hit times by pi divided by 180. Either method is totally fine. That would be 4.27 for my second radian. Try to put it all up there. My second radian would be 4.27. So if I wanted to convert the first one, I would have to go like this, and then times by pi divided by 180. 2.01. Or like I said, you can just change your calculator mode to radian, do the exact same problem again, use pi instead of 180. Either is fine. What I would just encourage you guys to do is show your work, so when I go to grade things, I know what you did. Because if it's all in the calculator, I have no idea. So the last example. We look first and we say this is cosecant, this is negative. So sine is y over r. Where is sine negative? Where is y negative? If x is positive, y goes down. That will be where y is negative. Or if x is negative, y also goes down. That's the other place where y would be negative. Excuse me. I don't have a inverse cosecant button, and I don't have a 1 over sine inverse button either, so I'm going to take cosecant and change it to sine. Reciprocate. Bless you. Reciprocate. If I reciprocate cosecant to sine, then I also have to reciprocate the other side of the equation. 0.1037. You can put the negative in front if you want. It doesn't really matter how you type it in your calculator. It's not simply the negative in the denominator, but it doesn't matter if you're just typing it in your calculator. So I'm in degree mode in my calculator. Oh, I didn't do it yet, sorry. What am I going to do? We're not multiplying by. We are taking the inverse sine. You guys remember when you did logarithms? Remember when you did logarithms? You're not multiplying by log. You're like taking a logarithm. So it's not, it looks like it is, but it's not multiplying. We're just doing the inverse sine. Okay, so that cancels out those, and I get theta. Okay, what mode am I in? I am in degree mode, and I got negative 7.0. I got negative 7.09. That is not one of my answers. It doesn't say it in the directions here. It says in the direction assignment, you have to be between 0 and 360, not including 360. This does not fit that number. The answer is tell us down 7.09 degrees. But that's not my answer. So my answer would be what? Oh, I'm sorry. So my answer is not just down 7.09. That's not my answer. We have to go all the way around the other side to get the answer. So what can you tell me for sure about this angle that I'm trying to find? Something obvious. It's in the fourth quadrant. I'm going to subtract from 360, and this is going to be a number that's quite close to 360, isn't it? It's going to be almost a full circle. Yep, so I'm going to take, and I'm going to subtract off that answer that I just got, which is like 7.09. Okay, so since my answer is negative on the calculator, I'm not going to subtract a negative number. I'm going to take 360 and add my answer, because my answer is already negative. So I get 300. Does that make sense for where it's sitting? 352.91, that is the second answer. So in my picture, what is the reference angle? What is the measurement of this little reference angle here? 7.09. That's how much it went down. So this one kind of gave us a reference angle. Neil?
It's like that, like when you do, so that gave us theta, right? Like how come on the number examples that it didn't give us theta? Like, why
This is not theta.
7.09.
It didn't give us 7. It gave us negative 7.
Like that's theta, right?
The positive 7 is the reference angle, yes.
No, I'm not saying like the reference. I'm saying like theta. Like when you do like the inverse sign, like, it's just
It will give you,
right?
so what we learn about later is it will give you one angle within 2 quadrants. It's going to only give you one angle. The calculator only gives you one angle within 2 quadrants. For example, if you use sine, it will give you one angle from here to here. And your calculator is programmed to give you an angle that's somewhere between negative pi over 2 to positive pi over 2. That's what it's programmed to do. So it doesn't give you the positive version because that's what our calculators are programmed to do.
So like on 7, it just like it gave you like the
7 for cosine, it is programmed to give us one angle in quadrants 1 and 2 from 0 to pi. That's what it's programmed to do.
So inverse cosine negative 2.34. Like aren't you like solving for theta there?
You are. It did give us one of the. When you say theta, because I've got so many thetas going on here. I should call these theta prime. It's not solving this angle. It's telling you one of the angles. That is between 0 and pi.
Oh, I
So this one down here,
just negative.
because of the way the calculator, it's telling us one of the angles from negative pi over 2 to positive pi over 2, but it's your job to tell me the positive version of that using coterminal angles rules. Okay? It's a little confusing about why, but that's what the program does. So from here, we have to find the other answer, which is starting at 0, rotating around to here. We know that our little theta is 7.09. How can I get this red angle here? A plus 7.09. But on my calculator, I'm going to use I'm not going to use just 7.09. I'm going to use the full thing. So I'm going to manipulate my calculator here. The older calculators, you can do this much easier with the newer ones. If you have the older calculators, I would probably do second answer, so I could get that question up and do it again. Just so you know. Then I would do 180 to add 7.09. So I'm going to subtract the answer, which is, oops. I'm going to subtract the answer because the answer is in my calculator to make it into addition. Or you can just do it all by hand. I'm just trying to use my calculator. I get an answer like 187.09. Does that make sense for where it is? Yeah. Just want to make sure that it makes sense, because that's the sometimes people. Okay, and then last task is we are going to find the two answers in radian. So how about this one? I will do this one by converting my calculator over instead of pi divided by 180, because I already showed you that way twice. I'll just do this one the other way where I change my mode. So if I change my mode, I'm going to do that same sine inverse, but I'm going to get answer. I'm going to get negative 1237. So negative 0.12. That becomes just this little, that becomes that little theta right here. And what we did before is we took a version of that, where we add, do the exact same thing, only it'll be 2 pi this time. So 2 pi plus my last answer will become subtraction. 6.16. Does that make sense for that quadrant? Who can tell me why 6.16 makes sense for this quadrant? Liam, I know you can tell me.
Because 2 pi is 6.28.
Right. 2 pi is 6.28, and then 6.16 is a little bit less than that. Okay, and then my other one over here, we needed to take, what did we do? We took, what was my second? Oh, it was up here. We took 180 and added that positive version. So I'm going to take pi and add in the negative or positive 0.1237, whatever it was. So pi, I'm going to add on that. Oops, so I have to change it to minus negative. And I get 3.27. And again, that has to make sense for the quadrant it's sitting in. Yes, Jill.
Can you go over how you got 180.09? I got lost.
It should be 187, but yeah.
Never mind.
It was just that confusing you? I'm sorry. When I talk, my hand doesn't always do what I've already thought about doing, because I get distracted and not thinking. Okay, so the worksheet you guys have. Let's do odd. Yep, let's do odd. Odd. You may do more if you'd like, but it's pretty long. Let's do odd. Guess what we'll do tomorrow? Do even tomorrow. You may need some time to review the stuff we did on Friday, so.